Hello everyone, this is Jason, and now I am in the robot lab. So this week we will work on the lab about robot safety. For the lab report, you need to enter your name, your partner name, and the date you perform this lab. And for this lab, you need to come to the end of this document. You need to answer 4 questions. The first question is about how to apply the safety to your robotic systems. Okay, and the second question is about what happened when the e-stop is pushed. And the third question is about the major components of the Fennec robot. Okay, and what's the mirrors we are provided by the Fennec robot to improve the safety of the Fennec robot. So let's bring this question to our lab. So the objective of this lab is to provide some information about the Fennec robot. So through this lab, you will identify the major components of Fennec robot and identify the junctions and axes of the Fennec robot. And you will also learn how to power on, power off the robot system. And finally, you will need to identify the mirrors for the safety guards. So let's get started. So here totally we have 4 documents for this week. I will have the lectures, the PowerPoint, help you to understand Fennec robot safety, and lab report, and reading assignment is about industrial robotics. And here we have the robot manual about safety. So you need to read through and find an answer from these documents. You need to read through this document to find the more information about the Fennec robot. So first, let me introduce the priority of the safety for the Fennec robot. Fennec robot set the people at the top priority for the safety, and the rest is external device and the robots and the tooling and the workpiece. So you can find the answer for the first question here. So the second question is about identify the major components of Fennec robot. So you can check the PowerPoint and the real robot. The first components for the Fennec robot is vision camera. Okay, let's come to the real robot. Okay, this camera is installed on the end of the arms, and the code, we have the code here. Okay, not very clear. Okay, this is the camera. So, and here is the end of the root. It's the end of arm toning. Here is the gripper. Okay, here is the gripper. This gripper is operated by a pneumatic system. So we need to have the air compressor. So air compressor is under the table. Okay, this one is the air compressor. So here it will provide the power to the grippers to operate the gripper to pick up the parts or workpiece. And here it's the transformer. For this robot, it will lead to 30 volts to operate, but the power supply in our lab is 110 volts. So we need to have the transformer to transfer the power to our leads. Okay, and on the side, here is the controller. The main parts of the robot is a controller. Let's look at the panel, operator panel. And as usual, the red one, the red push button, is E-stop. Okay, so when you press E-stop, and the robot, the controller, will disconnect the power to the motors in each arms, in each junction. Okay, we have servo motors here. So if we press, we have the servo motors here. Okay, in each junction. So when we press E-stop, the controller will disconnect the power to the servo motors. And on the side, this is E-stop. Okay, and this is two modes. One is auto mode, one is T1. T1 is a teach mode. Okay, auto mode is run for production. And for the auto mode, the robot will run in very fast speed, around 4,000 millimeters per second. But for the teach mode, the robot will run in up to 250 millimeters per second. For teach mode, we use that for the programming. So after you have the test, after you complete your programming and the test, you can run in auto mode. If your program is good and the speed and the position you already told. And this is the switch. Now the robot is on. Okay. If we need to power off, just twist. It can't clockwise. So if you need to power on the robot, you need it in clockwise. Okay, switch in clockwise. So this is a circle start push button we use for the auto mode. Okay, and here is the switch. The key. We need keys to turn on the panels. Okay, and here is the fan for the whole controller to dissipate the heat. And inside, I think it's something like a computer. Okay, so because now the robot is on, I cannot let you see inside of the controller. Okay, so we already introduced the main parts for the Fennec robot. The first one is the vision camera. The second one is the gripper. It's the end of the arm toning, second part, and the third part will be the arms. Okay, for these arms, for this robot is 6-degree freedom because they can move for the Cartesian coordinate system. They can move in X direction, Y direction, and Z direction, and the orientation about 3 axes. So this is a 6-degree freedom robot. The main parts we continue with. Sorry, let me introduce again. The main parts: camera, end of arm toning, the arms, and the compressor, and the transformer, and the controller, and the teacher pendant. Teacher pendant is used to communicate with the Fennec robot. Here is the teacher pendant. As you can see, we have the switch. We have the on or off. If we switch to the off, so the teacher pendant will not work to control the robot. So if you need to teach the robot, you need to switch the teacher pendant to on, okay, like this. And for the safety, we also have the E-stop on the teacher pendant. So if you have some emergency situation, you can press stop, and the controller will disconnect the power to the servo motors, so the robot will stop immediately. And for the safety, another device for the safety is night curtain under the table. You can see from this side. So I will run a program to check how it works. Okay, so if we get very close to the robot, if we want to run this program in auto mode, when we're very close to the robot will stop. If we will go away, and the robot will run again. So we will see how it works. Okay. So here is the main parts of the robot. Let me run this program. Okay. So we need to switch to the auto mode, because this I already tested this program is good. So we switch to the auto mode, and I run this for the demo. I need to find the program. Okay, car demo, and we need to disable this teach pendant, because I would like to run this program in auto. So it's all set. Let me put down the camera. Okay, you will see how this night curtain works. Okay, you can see we have the light is on, and the robot is working now. When I approach to the robot, okay, you can see the red light is on now. So because let me take this teach pendant. So if I go far away, the robot, the green light is on. So the robot will run in full speed. However, if we approach to the robot, okay, the yellow light is on, so the robot will slow down, half speed. Okay, let's go approach close to the robot. Robot will stop. So because the night curtain can detect us the distance to the robot. So let's go far away again. Okay, so now green light is on again. So let's go look at the robot. As you can see, the gripper is operated by the pneumatic system, so which will power by the air compressor. And for the safety concern, Fennec robot also provide another safety device for the on the teach pendant. As you can see, we have two yellow buttons. This is the 3-position switch. So when you release or squeeze tightly, the robot will shut off. Will disconnect the power to the robot. So robot will stop. So when you need to program a robot, you need hold this 3-position switch centered, okay? Not very tightly, or release. So normally I can hold this teaching pendant like this. My left hand can hold the three position switch. Okay, as you can see, if I release, here is the release, and a little bit hard is centered. Okay, so this is this is also called dead man switch. Now dead man switch is centered. If I push hard or squeeze tightly, the robot will stop, because now it's in auto mode. The teacher pendant is disabled, like this is off, so doesn't matter. Okay. This three position switch. Hold a little bit hard and squeeze tightly. Okay, like this, robot will stop. So this is a safety device for the Fenwick robot. And now I needed to introduce another safety device designed for the Fenwick robot. It's called dual check safety. Dual check safety, or called the DCS, is designed for the robot training card. So when you program robot or running the robot, the processor of the controller in the controller will check the position, the robot position, and also check the cartesian speed. Okay, so to prevent the robot from the collision with the wall or workpiece. So when we have the check the position in the area or the speed is too high, so the robot will stop move. Okay, immediately. So that's all about this lab. So I hope you can have a chance to operate this robot by yourself in our lab. So we will have the open labs if you would like to have this hands-on experience. Thank you.